is probably more common, but quadratic helps us understand the cops and the hairdryer. Exponential doesn't. Unless you're driving with an exponential rate of speed, in which case I suggest you give up your driver's license, because you shouldn't be doing that. But anyway, I want to get into quadratic modeling now. So the idea of linear modeling is you have constant slope. You guys figured that out almost on the first day. You have constant slope. The idea of quadratic modeling is you don't have constant slope, but you do have what's called constant acceleration. Constant acceleration. You've often heard of cars accelerating. What is acceleration? I mean, you're going to say it's the car's getting faster. Oh, please, please.
It's the rate of change.
It's the rate of change of the rate of change. Yes. So when you talk about rate of change, speed, for example, things like that. Rate of change is rise over run. Rise over run. So y value over an x value. Pretty straightforward. Y value over an x value. What acceleration generally is it's a y value over an x value squared. It's the rate of change of the rate of change. Now you'll see why you need to think about it that way as we go through the next couple days together. It's kind of a heady concept. When you talk about the force of gravity pulling something down, it's uniform. No matter what object you drop on Earth, whether it's a light marker or a 21-ounce bottle of water, it's exactly the same. A piece of paper, a feather, all of which fall at the exact same rate. Doesn't matter, the weight's irrelevant. The weight is irrelevant. What's something super heavy that I can drop? Something I have with me. Myself. Can I drop myself? No, not really. I'm not quite a circus performer. But the idea is that everything accelerates at the same rate of change due to gravity. But the units are kind of weird, right? The units are kind of, I want to get into that, like I said, probably next class together. So that's what this is showing you. This is the acceleration, the idea of acceleration, and that's what's actually going on, is the acceleration due to gravity is consistent. It's predictable. It's predictable. Have you ever been with somebody in the woods? Maybe you haven't, or if you watch Bear Grylls on TV, he can figure out how tall a cliff is by dropping a rock off and listening to when it hits the ground, if you can time it. He can. Some of it's pretty sketchball. I love that dude though. Love you, Bear. You fucking bullets. He can. But you can also tell how high a cliff is if you drop a rock and time how long it takes to hit the ground. You can reverse engineer the height of the cliff. I have a quiz for you guys that teaches you how to do that. Totally badass. Totally badass. But it's about quadratic. It's because that rock accelerates due to the force of gravity. Please, Josh.
Isn't that the same way that they calculate how far away lightning is when it strikes?
Is that the same? Hang on, let me think about that. That's the speed of sound, which is actually linear, I believe. Hang on, let me answer that question, Josh. We're going further. I believe, Amber, you're saying the same thing. You think you've heard the same thing?
Yeah.
I think it's the speed of sound is like 700 feet per second at sea level, or something like that. Let me just check. The speed of sound is different than the speed of light. You ever notice that? When you're out in the woods, watch somebody chop wood from a great distance away, you see this, and then a second later you hear the pop. Speed of light is 3 times 10 to the 8th meters per second. That's ludicrous. So fast, 300 million meters per second. Speed of sound is like 700 feet a second, which is still pretty damn fast, but nothing compared to the speed of light. Let's just Google speed of sound. Speed up, there we go. And, they're actually, at sea level.
Meters.
At sea level, 340 meters, so about 1,000 feet a second. I was off by a couple hundred feet. That means for every second it travels, it covers 1,000 feet. 340 meters, 1,000 feet. That means if you see the lightning, allegedly, and then you count, that's right,
Yep.
every 5 seconds it's a mile. That's the old rule of thumb, isn't it?
Yes.
Every 5 seconds you count, it's a mile, because every second it covers about 1,000 feet, which is roughly 1/5 of a mile. Oh, that's clever.
Yeah.
I just should have thought of that. So when you watch the lightning strike, that's speed of light. That's instantaneous, basically. Then you start counting. 1 1,000, 2 1,000, 3. If it took 3, that means it's 3,000 feet away, or about 60% of a mile away, or whatever that is. So that's purely linear, though. Josh, that's this. That's linear. Every second is 1,000 feet. Every second is 1,000 feet. If it were quadratic, it would be, okay, this second it picked up 1,000, this second it picked up 2,000, this second it picked up 4,000, this second it picked up 8,000, or that's actually exponential, but you see the point though. The point is that it's increasing. With every increase here, it's increasing more or less, but predictable amounts in the other direction. Is that fair?
Yeah.
Thank you for that. That was a wonderful connection. Wonderful connection. So,